right, so welcome back to statistics. We are on to our fourth unit, and this unit is all about data collection. All right, so up until this point, we've sort of been taking the data side for granted, and it's just like, oh, here's your data. Use it, analyze it, run calculations on it. This is sort of taking a step back and saying, all right, how did we actually get this data in the first place? And what do we have to worry about when we're collecting data? Stats is very much a garbage in, garbage out type situation. What do I mean by that? If the data that you're gathering is bad, all of your analysis is going to be bad. All right. There's nothing we can do to really overcome bad data or biased data. I mean, there are some things, but for the most part, it's up to us to make sure that the data we're gathering is of high quality. And if the data is high quality, we have a better chance of producing a high quality analysis or interpretation of the data. All right. So we're going to start here with just some basic definitions, and we're going to keep it pretty light because this is the first day and there's like a break coming up. So I don't want to go too deep into anything leading into that. All right, so sampling happens whenever a subgroup of a population is chosen. This can be for an experiment, a survey, or any other mode of data collection. Let's start with what can go wrong. All right, so we're going to put out some definitions. We're going to talk about some stuff that we want to avoid, and then we're going to talk about something that's a little better. All right, so first things first, population. All right, when we refer to population in here, we're talking about the entire group of individuals about which we want information. All right. So population, everyone that deals with like whatever topic you're investigating, all right? The entire group of individuals about which we want information. All right. Sample is a subset of the population. All right. It is the part of the population from which we actually collect information. All right. And then just a note, we use this information to draw conclusions about the entire population. All right, so we're just dealt with this reality that it's usually not practical or it's cost prohibitive to talk to an entire population or to survey an entire population or to perform an experiment on an entire population. So instead, we get a sample, we get a subset of that population, and then what we're hoping is that sample is representative of the larger group. And if that sample is representative of the larger group, then the conclusions we draw from the sample can be extended to the population. Now, where we run into trouble is when the sample is not representative of the population, right? And there's all sorts of reasons that that can happen. But then we're in this situation where we have a sample that's not representative. We might not realize that it doesn't represent the population. So then the conclusions we draw end up being inaccurate. They lead us to make bad decisions, and those bad decisions could cost time, they could cost money, they could cost all sorts of things. All right, so it's important that when we're building our sample, we're as representative as possible so that we don't fall into that trap and leading to bad decisions. So what's one way that can be bad? All right. All right. A voluntary response sample. All right. This is something that happens all the time, and it's something that really shouldn't happen because it leads to bad information. So, what is a voluntary response sample? All right. When individuals can choose on their own to participate in the sample. Now, I want to clarify this a little bit because obviously somebody can always choose whether or not they participate. This is referring to the selection process. So, like, let me put it this way: like, I could design a great survey. I could have a perfect group that I have selected through whatever mechanism I've decided that is totally representative of the population, right? Then I could issue the survey. I could issue whatever data collection method I'm doing. And some people just might refuse to participate, right? They might not answer their phone or they might hang up on me, right? That's not what we're talking about when we say voluntary response, right? Voluntary response is like saying, hey, there's this survey out here on blah, blah, blah. If you're interested, come fill it out. So the difference here is we're not like choosing any individuals. We're just sort of putting it out there and saying, hey, there's a survey. Take it if you're interested. All right. That's a very different situation than, all right, I randomly selected a bunch of participants and issued a survey, but not everybody returned their surveys. All right. So a voluntary response is referring to like you're not really selecting a group at all. You're just designing the survey and then generally asking people to fill it out. All right. Now, why is this a bad thing? Um, Generally, only the extremes tend to respond. So if you send me a survey and say, this is for a research project, please, fill it out. We're trying to get a representative sample. There's a chance that I'm going to do that. I'm going to say, all right, fine, like I can do that. It's only going to take 2 seconds, not a big deal, and I'll send it back. If it's just, hey, there's a survey about this topic, feel free to fill it out. I'm probably not going to take time out of my day to fill it out if my responses are going to be, yeah, I don't really care one way or another, right? The only way I'm going to actually go and fill out that survey when it's presented in that manner is if I feel really strongly about something. So the voluntary response sample is usually extremely biased because you're only getting people at either extreme and you're totally missing the middle of the spectrum when you just make something completely voluntary or like opt in. You have to make an effort to actually take the survey because you weren't selected. It was just presented and you could choose to take it if you wanted to. All right, so that's bad. All right. Second, convenience sample. All right. This is when individuals who are conveniently available are used in your sample or for your sample. Let's say used for your sample. Now, there might be times when you're conducting a sample and the people are conveniently available, but this is saying like, all right, I want to know opinions of high schoolers across the country. And I'm like, making a survey and sending it out to like California seems like a pain in the butt. So I'm just going to ask kids at Ichabod and assume that, that's good enough. All right. That's an example of a convenience sample. You're basically cutting corners because you don't want to do a full representative sample. and you just talk to the people near you or around you and use that as your data. So why is this bad? May not be representative of the population. Right? I mean, it could be. You could get lucky, and your convenience sample might be representative of the population as well. But in most cases, it's probably not going to be representative of the population. All right. So again, it's easy, it's less expensive, but it's not great. So if these are some of the bad ways of doing it, what's a better way of doing it? All right. So the most simple, all right, and it's not the only way of doing it. We're going to see that there are other techniques that are also very effective, but the most simple is appropriately called the simple random sample, or SRS. All right, and it is a sample of size n in which each set, so it's a sample of size n in which each set of n elements in the population has an equal chance of selection. So that's a technical definition. What's a more, plain English definition is every combination should be possible and every combination should have the same chance of being selected. So basically, we're not putting any restrictions on this, and we're giving everybody an equal chance of being selected. All right, so we're randomly selecting people. We're not saying like, oh, we need some from this group and some from that group and some from this group. We're just saying, all right, we're randomly selecting people, and everybody has the same chance of being selected. All right, so we're not favoring one group over another. We're not targeting one group over another. We're just saying, all right, here's our population. We're going to get a sample of 100 people. Everybody has the same chance of being selected. And, the first 100 we randomly select. That's our group, right? And why is this the best? It helps avoid any selection bias. All right. We're kind of leaving it out of our hands. We're just saying, all right, here's our group. Let's randomly pick a whole bunch of people, and what we get is what we get. But we as the researcher are not able to influence the process in any way. All right, so let's take a look at the back here and see this kind of play out in some examples. So the Consumers Union asked all subscribers whether they had used alternative medical treatments, and if so, whether they had benefited from them. For almost all of the treatments, approximately 20% of those responding reported cures or substantial improvements in their condition. So here's a scenario. Here's something that happened. And then we're going to answer some questions about that. All right, so what is the sample? What is the population? So let's go back to our definitions here. So the population is the entire group of individuals about which we want information. So we're trying to find out information about alternative medical treatments. And we're trying to find out if you use them, what did you think about them? So let's actually start with the population. The population is people that use alternative medical treatments. Those are the opinions that we're really trying to get here is if you've used these treatments, what do you think about them? Or what results have you discovered? What is the sample? Well, the Consumers Union only asked their subscribers, all right? They didn't find out an exhaustive list of everyone that used alternative medical treatments. They only talked to their subscribers. So the sample is subscribers who used alternative medical treatments. All right, so they didn't go and try to get a list of everybody. They were just like, well, let's just use our subscribers because that's easier. All right. Now, is this a simple random sample? Hopefully, by the way I just described that, you're recognizing that no. This is more of a convenience sample. Okay. And it's possible, so if what problems do we foresee? It's possible that consumer union subscribers are not representative of the larger population. Okay. Now, if they were only concerned with their subscribers' opinions, then maybe this would be okay. Like if they weren't trying to find the global opinion on this stuff, and for whatever reason, they were just trying to figure out how their members felt about it because they were only interested in like doing something for their members, then this might be okay. But if you're trying to find like overall satisfaction with alternative medical treatments, this might not be representative because you only looked at your subscribers, and maybe there's some quality of your subscribers that's different from people that don't subscribe to your consumer union. So it's not always black and white. It kind of depends on how they're using that information and sort of the context around the situation. All right, researchers waited outside a bar they had randomly selected from a list of such establishments. They stopped the first 10 people who came out of the bar and asked them whether he or she thought drinking and driving was a serious problem. All right, so what is the sample? What is the population? All right, now in this case, the sample for us was, the 10 people at the bar. The 10 people from the bar. What is the population? Now, again, we're not the ones defining the research question here, so we have to speculate a little bit. Are they specifically targeting bars? Is their population people that frequent bars? Is their population everyone? Is their population adults of legal age? We don't know exactly what their research question is, so we don't know exactly how to define the population. But considering they're working from bars, we could say that it's probably adults of legal drinking age. All right. Again, we don't know. We're not the researchers. We don't know exactly what they're planning to do with this information. But based on what we have, that's what we can go with. All right. Is this a simple random sample? If not, what problems do you foresee with the sampling method? All right. So clearly it's not. No, this is not a SRS, simple random sample. All right. Simple random sample. Probably the last time I'm going to write that out, and then I'm just going to keep using SRS. There are all sorts of problems here. All right. So issues. One, we limited ourselves to a single bar. All right. So not great, because what if this bar has a different clientele than other bars that have different clienteles than other bars? So we limit ourselves to a single bar. So at the very start, we're kind of cutting out and making it less likely that we're going to get a representative sample. Two, it's possible those who leave early in the night differ from those who leave late. Right? Because it said we're stopping the first 10 people that came out. So it's possible that those people are going to have different opinions than people that are spending all night there and aren't going to be leaving for several hours. So lots of issues. Again, most of this revolves around convenience. But again, not a great situation here. All right, for their class project, a group of students decided to survey the student body to assess opinions about a proposed student center. Their sample of 200 contained 50 freshmen, 50 sophomores, 50 juniors, 50 seniors. What is the sample? What is the population? All right, so this one's a little more straightforward. But the sample here would be the, 50 students from each grade. The population would be all students. Now, this approach is better. All right, this approach is better, especially if these students were selected randomly. All right, if these students were selected randomly, this is an improvement over what we've just seen. All right, but it's still not a simple random sample. All right. Now, the issues are a little less obvious here, but the main one is if the grades don't have the same number of total students, we might be overrepresenting some grades. Should have given myself more space for this by taking 50 of each. All right. Now, let's just be super exaggerated here. All right. Let's say this is some bizarre school that has 1,000 seniors, 500 juniors, 250 sophomores, and only 50 freshmen. Right. Well, you're talking to 100% of the freshmen. You're talking to 1/5 of the sophomores, you're talking to a tenth of the juniors, and so on down the line there. All right, so you're getting way more representation from the freshmen than you are from the sophomores, the juniors, the seniors. Now, if these are relatively equal, there's about as many freshmen as there are sophomores, as there are juniors, as there are seniors, and these students are selected randomly, then this can actually be a good design. It's called a stratified sample, and there's no problem with it. But based on the information we have here, we don't know whether these grades are of equal size. And if they're not of equal size, forcing these to be equal is not necessarily a good decision. All right. And also, SRSs don't divide data into groups. All right, so this is actually what's called a stratified sample, which is good, but it does not qualify it as an SRS. All right, last one here. Dairy inspectors took a list of all farms in Rensselaer County and put all of the names of the farms in a hat. The inspector then closed his eyes and chose 5 farms to visit to take samples of milk. What is the sample? What is the population? So the sample in this case is the 5 farms that were selected. Again, we have to sort of assume that we know what the researchers are looking here, but I'm going to assume that they're focused on Rensselaer County. I'm not going to assume that this isn't a study about all, dairy farms. I'm going to say that the population is farms in Rensselaer County. And then, is this a simple random sample? Finally, the answer is yes. All right. Each farm has the same chance of being selected. And we're not placing any restrictions on the groups. Or better yet, restrictions on who is selected. All right, so again, this isn't the only way to do it, a simple random sample, but it is one of the more effective ways because we don't have to worry about bias. We're not overrepresenting, underrepresenting. We're just randomly picking people and saying, all right, this is who we got. It's from our population of interest. So by randomly selecting them, we know that we're not either consciously or unconsciously influencing the process in any way. Now, again, it's not the only way to do it. We're going to see that there are other ways to do it that are valid, that are useful, and can sometimes be superior to the simple random sample. But this is sort of our starting point of random selection where there's no influence. We're just saying, here's the population, and I'm randomly selecting people from that population. I'm not taking any shortcuts by forcing different groups. I'm not taking any shortcuts by, limiting myself to a single location or a single group of people. I'm saying, here's my entire population that I'm concerned with. Let me just randomly select from that population. All right, so again, this is just our brief intro. We're going to go deeper into this as the unit goes on, but this just gives us a starting point to talk about some of these issues. All right, let me know if you have any questions, and have a great day.